Hello everyone. In today's lecture, we are going to study about remaining types of the interpolation. Okay, so in the last lecture, we studied about what is interpolation. Okay, so interpolation is a collection of methods used to solve the computer graphics problems, and the interpolant is used to change one number into another. Okay, so just like in the moving of virtual camera, changing the camera place, or coloring or brightness of the virtual light source, the interpolation concept is used. Okay, so in the last lecture we study about the point linear interpolation. Okay, so we next study the point which is non-linear interpolation. Okay, so in linear interpolation we have seen that linear interpolant equal steps in the parameter t gives rise to equal steps in the interpolated values. Okay, तर याच्यामध्ये जर याच्यामध्ये लिनियर इंटरपोलंट इक्वल्स असतील तर त्याच्यामध्ये जे काही इंटरपोलेटेड व्हॅल्यूज असतील तर त्या सुद्धा याच्यामध्ये काय येतात तर इक्वल येतात. ओके, सो but we need equal step in the parameter, and it gives rise the unequal steps in the interpolated values. Okay, जर याच्यामध्ये या टाइप मध्ये व्हॅल्यूज असतील त्याच्यामध्ये जर इक्वल स्टेप्स असतील पॅरामीटरच्या आणि त्याच्यामध्ये जर अनइक्वल इंटरपोलेटेड व्हॅल्यूज कॅल्क्युलेट करायचे असतील तर त्याच्यामध्ये हे नॉन लिनियर इंटरपोलेशन काय होतं यूज होतं. Okay, so for that non-linear interpolation we use trigonometric functions or by using polynomials. म्हणजे याच्यामध्ये पॉलिनॉमियल्सचा यूज होतो किंवा ट्रिगोनोमेट्रिक फंक्शन्सचा यूज केला जातो नॉन लिनियर इंटरपोलेशन मध्ये. देन वी स्टडी अबाउट द ट्रिगोनोमेट्रिक इंटरपोलेशन. ओके, सो we know that sin square beta plus cos square beta which is equal to 1, so it fulfills one requirement of interpolant, that is the term must sum to 1. Okay, that means the addition is equal to 1. Okay, so if the values of beta varies from 0 to pi by 2, that is cos square beta modifies between 1 and 0 and sin square beta modifies between 0 and 1. Okay, जर याच्यामध्ये बीटाची व्हॅल्यू चेंज केली 0 to pi by 2 यामध्ये तर त्याच्यामध्ये cos square बीटाची व्हॅल्यू मॉडिफाय होऊ शकते बिटवीन 1 to 0. ओके, तर त्या टाइप मध्ये sin square बीटाची व्हॅल्यू मॉडिफाय होऊ शकते 0 to 1, that is 0 and 1. So it is used to change the interpolated values, that is n1 and n2, which gives the equation as n is equal to n1 cos square t plus n2 sin square t, where t is rise between greater than or equal to 0 and less than or equal to pi by 2. Okay, so there is an example which is given in the diagram 5.2.1. so here the value of n1 is 1 and n2 is 3. Okay, so here is the equation, that is n is equal to this term. Then in the equation, this equation, that is 5.2.a, we will get the curves shown in the figure. If we apply this interpolant to two 2D points in space 1, 1 and 4, 3, we will get a straight line interpolation, but the distribution of points is non-linear. Okay, as shown in figure C. Okay, so याच्यामध्ये हा जर suppose first curve असतील. Okay, this is first curve and this is second curve. Okay, after that we apply the interpolation. Okay, at the point n1 is equal to 1 and n2 is equal to 3. Okay, so this is the another curve which is applied by using the 2 points, that is 1, 1 and 4, 3. Okay, then the curve like this, that is okay. So in first diagram cos square beta and sin square beta curve. Okay, हा cos square beta आणि sin square beta चा curve आहे. त्याच्यानंतर सेकंड डायग्राम मध्ये काय आहे तर ट्रिगोनोमेट्रिक इंटरपोलंट फॉर इंटरपोलेटिंग बिटवीन 1 and 3. ओके, याच्यामध्ये 1 and 3 याच्यामध्ये जे काही इंटरपोलेशन आहे तर हे इंटरपोलेशन याच्यामध्ये दाखवलेलं आहे. इथे हा तुम्हाला कर्व दिसत असेल 3 पॉइंट. ओके, सो दिस इज 1 and 3 interpolation curve, and next one interpolating between 2 points 1, 1 and 4, 3. Okay, this is 1, 1 and 4, 3. Okay, this is 4 and 3. Okay, this is the curve. So By using trigonometric interpolation, we use that types of curves in the graphical applications. Then the next type is cubic interpolation. Here we will use cubic polynomial to form the basis of the interpolant. So we will use cubic blending functions as it provides extra flexibility. Okay. So here we use this type of function, that is b1 is equal to 8t cube plus bt square plus ct plus d. And the final interpolant is n is equal to v1 v2 dot n1 n2. Okay, we write in the matrix form of the cubic interpolation. So the following are the requirements to find the values of the constants associated with the polynomials v1 and v2. A cubic function v2 must increase from 0 to 1 for t is greater than or equal to 0 and less than or equal to 1. ओके, क्युबिक फंक्शन v2 असेल त्याची व्हॅल्यू इन्क्रीज होणार आहे 0 to 1 पर्यंत, पण त्याची जी काही व्हॅल्यू आहे ती 0 आणि 1 या मिडल मध्येच असणार आहे. ओके, then the slope at a point t must equal the slope at the point 1 minus t. ओके, तर याच्यामध्ये जर त्या पॉइंटचा स्लोप t या पॉइंटला जो असेल तर तो इक्वल असणार आहे ऍट द पॉइंट 1 minus t. या पॉइंटला सुद्धा तो काय असणार आहे, इक्वल असणार आहे. ओके, the value v2 at any point t must also produce 1 minus v2 at 1 minus t, and this guarantees curve symmetry. Okay, याच्यामध्ये curve symmetry सुद्धा maintain केली जाते. So to accomplish the first requirement, we use this equation, that is v2 is equal to 8t cube plus bt square plus ct plus d. Therefore, d is equal to 0, t is equal to 0 for v2, it is equal to 0. And when that values are put in the equation, then the equation of v2, which is equal to a plus b plus c, and t is equal, where t is equal to 1. Okay, याच्यामध्ये जेव्हा t ची व्हॅल्यू 1 असेल तेव्हा हे इक्वेशन येणार आहे, v2 is equal to a plus b plus c. And when the value of d is equal to 0 and t is equal to 0, then the value of v2 is equal to 0. ओके, या इक्वेशन मध्ये जर v2 सॉरी d आणि t ची व्हॅल्यू 0 पुटअप केली तर हे इक्वेशन 0 येणार आहे. That is the values are comes between 0 and 1. Okay, so this is the first requirement. Then the second requirement is the slope at a point t must equal the slope at the point 1 minus t, and it guarantees slope symmetry over the range of the function. So for that requirement, we take the derivation, that is dv2 divided by dt. Okay, in this derivation, so we take the derivation of this particular equation, that is 80 cube plus bt square plus ct plus d. When we take the derivation, then the derivation of the term 80 cube, okay, with respect to t, we take here the derivation with respect to t. So the terms are first term is 80 cube, then the derivation of this term is 3at square. Okay, 3at square plus by mistake here 3 is printed, so this term is 3at square plus the derivation of bt square is 2pt, then the derivation of ct is c, and the derivation of d is 0. Okay, so here d is constant, so that's why their derivation is 0. And here ct, that means the only single t, so their derivation is 1. So here the term is come at replacement of ct is c. So this is equal to 3a, which is taken common here, then in bracket 1 minus t bracket square plus 2b in bracket 1 minus t plus c. Okay, by equating the constant, we get c is equal to 0 and 0 is equal to 3a plus 2b. So to accomplish the third requirement, we get 80 cube plus bt square, which is equal to 1 minus the remaining terms are taken in the bracket. So just see here, a in bracket 1 minus t cube plus b into 1 minus t square. And we discover by solving this equation, we take it as 1 is equal to a plus b, but 3a plus 2b, which is equal to 0. So the values of a are calculated, which is a is equal to minus 2 and b is equal to 3. So the value of V2, which is equal to 2t cube plus 3t square. Okay, so these are the three requirements for the cubic interpolation, which are solving here by taking the equation. So we don't study that next point, which is comes under cubic interpolation, so there is no need to study that particular point. Then the next one is interpolating vectors. So to this point, we have been interpolating between a pair of numbers. So for that interpolation between the pair of numbers, we use the interpolating vector. Okay, so because of vector consists of both the magnitude and direction, and when interpolation between two vectors takes place, then ensure that these both quantities are preserved. Okay, so there is a need to ensure about the quantities of that particular vectors, which is magnitude and direction, when using the interpolation. Okay, so for example, we if we are interpolating the x and y components of the vector, and these vectors are 2 and 3. Here we take t because of we take the row notation for the vector, and 4 7 the AMID vectors would preserve the change of orientation and it ignores the change in magnitude. Okay, so if we want to preserve both, first understand how the interpolation should operate. So just see this diagram. So you can see about the two vectors, that is v1 and v2. This is the first vector v1 and this is v2, and these are separated by angle theta. Okay, so the interpolated vector v, so okay, this is v1, this is v2, and this is the interpolated vector v, and it is defined as proportion of v1 and proportion of v2. Okay, याच्यामध्ये मिडल मधला हा इंटरपोलेशन वेक्टर काढलेला आहे याच्यामध्ये. सो द इक्वेशन ऑफ इंटरपोलेटेड वेक्टर इज v इज इक्वल टू a v1 plus b v2. Okay, so this is the length from the origin of the particular vector. So let's define the values of a and b such that they are a function of the separating angle theta. So the vector is t raised to theta from v1 and 1 minus t raised to theta from v2. ओके, याच्यामध्ये ए आणि बी ची व्हॅल्यू कशी कॅल्क्युलेट केलेली आहे तर या टाइप मध्ये आहे बघा. इक्वेशन a divided by sin 1 minus t raised to theta and it is equal to b divided by sin t raised to theta. ओके, तर आता याच्यामध्ये t raised to theta काय आहे तर जो वेक्टर आहे v from v1 and the distance is calculated by taking 1 minus t raised to theta. Okay, and the vector v from the another vector v2 which is calculated as t raised to theta. Okay, so here we take m is equal to a cos t theta, n is equal to b cos 1 minus theta raised to theta, then m plus n is equal to 1. Okay, and from the equation 2.27, okay, by using the equation we solve it as b is equal to a sin t theta divided by sin 1 minus t raised to theta. Okay, by solving this formula we find the final interpolation, which is equal to v is equal to sin 1 minus t raised to theta divided by sin theta into v1 plus sin t theta divided by sin theta into v2. Okay, then the next point is interpolating quaternions. So the interpolants two works with quaternions, that is interpolated quaternion q for given two quaternions q1 and q2 is given by. Okay, so we just study about the quaternion in our first unit in detail information about the quaternion. Okay, so we just study here the interpolating quaternion. So we take the two quaternions, that is q1 and q2, where q is equal to sin 1 minus t raised to theta divided by sin theta into q1 plus sin t theta divided by sin theta into q2. Okay, if the interpolating vectors and the angle theta between the two vectors is not given, then you will get it by using the dot product formula. म्हणजे याच्यामध्ये जर टू वेक्टर्सची व्हॅल्यू दिलेली नसेल किंवा त्याच्यामध्ये माहिती नसेल तर त्याच्यामध्ये डॉट प्रॉडक्ट फॉर्म्युला यूज करून इंटरपोलेटिंग वेक्टर आपण काय करू शकतो, काढू शकतो. सो cos theta is equal to v1 v2 divided by determinant of v1 into determinant of v2. So cos theta, which is equal to x1 x2 plus y1 y2 plus z1 z2 divided by determinant of v1 into determinant of v2. Okay, so to interpolate quaternions to get the theta, 4D dot product of the two quaternions is taken. Okay, याच्यामध्ये 4D dot product घेतलेला आहे याच्यामध्ये. तर बघा इक्वेशन काय येणार आहे, cos theta which is equal to q1 q2 divided by determinant of q1 and determinant of q2. Then by solving these quaternions, we take it as cos theta is equal to s1 s2 plus x1 x2 plus y1 y2 plus z1 z2 divided by determinant of q1 and determinant of q2. Okay, so by we replace here v1 v2 as q1 q2. Okay, v1 v2 हे जे वेक्टर्स आहेत ते quaternion रिप्लेस करायचे आहेत. Okay, so just see this formula cos theta and this is the formula for quaternion. Okay, then this formula for uh, vectors by using the three coordinates, that is x, y and z, and this is the formula for x, y, z coordinate using quaternion. Okay, so at the replacement of vector we use here quaternions. So if we use unit quaternion जर यूज केलेला असेल तर इक्वेशन काय येणार आहे, तर cos theta which is equal to s1 s2 plus x1 x2 plus y1 y2 plus z1 z2. Okay, so unit quaternion means unit quaternion having the value 1. Okay, so here denominator is removed, so the equation of unit vector is this. Okay, so when we interpolate between a pair of quaternions, suppose there are two quaternions which is q1 and q2 and they rotate about the angles, that is 0 degree and 90 degree about the z axis, then the quaternions are q1 is equal to cos 0 degree divided by 2 sin 0 degree divided by 2 and 0 0 1. Okay, these equations are given in the unit first under the point quaternions. Okay, हे पॉइंट तुम्हाला फर्स्ट युनिट मध्ये quaternions या पॉइंटच्या अंडर झालेले आहेत आणि ते इक्वेशन फक्त इथे जस्ट यूज केलेले आहेत. सो that particular equations are given in that particular quaternion point deeply. So just see here the equation for q2 which is equal to cos 90 degree divided by 2 sin 90 degree divided by 2 and 0 0 1. Okay, so by solving these particular values we get the values of q1 which is equal to 1 and in bracket 0 0 0, and in q2 the values of 0.771 and 0 0 0.7071. Okay, so find the value of theta. We take the equation as cos theta which is equal to 0.7071 plus 000 plus. Okay, the 3 times 0 घ्यायचा आहे ऍडिशन साठी, and the cos inverse of 0.7071 is 45 degree. Okay, या इक्वेशन मध्ये या व्हॅल्यूचा पर्टिक्युलर cos inverse घ्यायचा आहे. Okay, that is cos inverse of 0.7071 which is 45 degree. That means the angle theta which is equal to 45 degree. Okay, so if we take t is equal to 0.5, the interpolated quaternion is. Okay, जर याच्यामध्ये t ची व्हॅल्यू जर 0.1 कन्सिडर केली तर त्याच्यामध्ये quaternion व्हॅल्यू काय येणार आहे. ओके, सो by using the interpolated quaternion we got a unit quaternion as the sum of squares root is 1. Okay, so another example is here given related to the interpolating quaternions. Okay, then the next point is curve. Okay, so in this point we just study about the mathematics behind the 2D curves. Okay, 2D curves च्या behind मध्ये कोणते कोणते mathematical concepts यूज होतात. You just know about the curve. Okay, तुम्हाला कर्व म्हणजे काय असे माहिती असेल. Okay, so in the above diagrams you just see the curves. Okay, so this is the parabola curve. Okay, so these are the another sine wave curves. Okay, so these are the waves, or these are the curves. Okay, there are different ways to use the curves. This is one of the curve here given. Okay, this is parabola type curve. So in this point we just study about the 2 points which are used in curve concept. First one is circle and second one is ellipse. Okay, the equation of circle is, you may know that, x square plus y square, which is equal to r square. Okay, here r is the radius. Okay, circle equation is not suitable for drawing the curve. To determine the coordinates of any point on the circumference in terms of some parameter, two functions are required. Okay, so there is no suitable for drawing the curve, or this is not possible to draw the particular curve by using only the circle equation. So for that we use another two equations related to the circle, which is x is equal to r cos t and y is equal to r sin t, where t is greater than or equal to 0 and less than or equal to 2 pi. Okay, the parameter t can be vary over the range 0 to 2 pi. The curve of the circumference can be traced out, or the circle is isolated for selecting an appropriate range of t. Okay, so here we take the appropriate range t between greater than or equal to 0 and less than or equal to 2 pi, and we use that two particular functions, that is x is equal to r cos t and y is equal to r sin t. Okay, so this is the first concept which is comes under curves, that is circle. Then the next one is ellipse. The equation of ellipse is x square divided by r square major radius plus y square divided by r square minimum radius. Okay, a major radius and a minor radius. Okay, so the parametric form which is used here are x is equal to r major radii into cos t and y is equal to r minimum radii sin t, where t is greater than or equal to 0 and less than or equal to 2 pi. Okay, so these two concepts are used in the curve. So we use the two points here, that is circle and ellipse. Okay, so in this lecture we study about the points interpolation, linear interpolation. Then another type is non-linear interpolation. The next one is trigonometric interpolation. Okay, so in these points there are maximum data given, so there is no need to take all that particular data. So you just take out only the data which is needed. Okay, so you just take the theoretical points here and the equations. Okay, so there is no need to take all that particular concepts given in that particular point. Okay, then cubic interpolation, then interpolating vectors, then interpolating quaternions and curves. Okay, in curves there are two mathematical concepts used, which is circle and ellipse. Okay, so we just stop here today's lecture. So if there are any problem related to this lecture, then contact me. Okay, so in the next lecture we studied about the Bezier curves, and in detail we study that particular Bezier curve and the another points which comes under this chapter. Okay, thank you.